Okay, we're going to be having a look at Chapter 2 in the Year 1 Stats book. This is on measures of location and spread, and a lot of this you'll have met at GCSE, but there are a couple of really important differences. Measures of location and spread, you've met measures of location. These are things that tell you where a certain feature of your data is. For instance, the mode, or the mean, or the median. These are called measures of location because they tell you where is a certain fact about our data set. So where is the most common, where is the middle thing. You've also met some spread things. You will have met range. You might have met interquartile range. You might have also met standard deviation or sigma, either as part of GCSE or as part of one of your other subjects. If you've not met standard deviation, don't worry too much about it. We'll meet it more in this coming chapter. First thing we have to be aware of is there are two very different types of data set. The type of data set we've got on the left here contains actual values. We'll see here there's a frequency of 3 which had an x value of 15, so that means our data set started with 3 15s. So this data set, even though it's arranged in a table, is actually a list of data. It's all of the actual values, and after the 3 15s we start on 15.5s, and there are 17 of these. So here we've got all the original data. It's just been organised in a table. We could have put this in a list, we could have put it in a stem and leaf, but this is actual data. On the right hand side we've got grouped data, where they've taken all of the data and grouped it into certain values. So this 4 here means that there are 4 things in this class 0 to 5, but we actually don't have the information to tell if they're all 0s, they're all 5s. It could be a mix of one of each. We could have 3 4s, a 2 and a 3. So we don't have the actual data here. We've got very different methods to use for these two different tables of data. Even though they both look like they're the same kind of thing, they're actually fundamentally different. So whenever you get some of these methods, there's going to be one method usually for exact data, and sometimes a different method for grouped data, which is grouped into different options under the same category. Notation is really important in stats. We're going to go over a couple of these symbols because we need to make sure that everyone sees the same thing when they see these symbols. Again, you might have met some of these symbols before, you might not have met them before. So we're going to use this capital sigma up here to mean the sum of. So this is the sum of, and we can see later on there's a sigma down here with something next to it. This tells us what we're summing up. So it's the sum of, and then whatever happens to come next. F we're going to use as shorthand for frequency, which means sigma f is the sum of the frequency which we're going to call n, our total number of things. So if you add up all the frequencies, that's what sum means, you'll end up with a total n. X we're going to use for any piece of data, so a result, a value. So that means things like sigma fx is the sum of f multiplied by x. So this starts to give almost like a sentence. So this says add up all of the frequencies multiplied by the x values, the results. We'll see things like this coming up later. It's just important to start realizing that these are sums. Scrolling down here we have an x with a line on the top. This we're going to have as the mean of x. And we're going to pronounce this x bar. There is one quick little note that I want to put in here. When you're doing sums, they have this hidden set of brackets in here. So it's not sum of f multiplied by x. It's not sum of f multiplied by sum of x. There's a hidden set of brackets after a sum, and you have to work out the thing inside the brackets before you start summing it. So we're going to use some of this notation as we go through. just to recap a couple of the GCSE measures you've met, the mode is simply the one that appears the most. Sometimes it's called the modal value. So looking through a list of data, we can pick out which one appears the most. For instance, in here there are 3 6s, so the mode is quite obviously 6. If there are 2 modes, for instance we've got 2 6s and also 2 7s, 3 of each, so we've got 2 modes here. Sometimes this is called bimodal, but we've got 2 values for the mode of 6 and 7. When we start to look at grouped data in here, you'll notice now we use the words modal class, because we don't know what the actual mode was. We do know that it was in this category where the largest number of bits of data fell. So the modal class is this 30 to 34. However, it's quite important to realise that the mode wasn't necessarily in this class. These things in here between 30 and 34 could be evenly spread out, and we could actually, in this class up here, have had 8 29s. But we don't know, because this is grouped data. We haven't got the original set of data. We just have to draw conclusions based on the data that we can see. So in here it would suggest the modal class is this 30 to 34. It's most likely to contain the mean, but without the actual data we don't know for certain. So that's the mode. We've met mode at GCSE, not really much has changed. Just remember, if we've got this group data, we're going to use the words modal class rather than mode. The median, also for list data, for data where we have everything, hasn't really changed. We need to make sure they're in order from largest to smallest, and we're going to go through the middle. Some people like to cross things off at the starts and ends and end up in the middle. So here we do things like this one and this one, 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 and we end up with 6. Some people like to use this rule where you add 1 to the number of bits of data and half it, and this will give you an idea. We should be after the 6th thing, so going through 1, 2, 3, 4, 5. Oh, that does give us the 6th thing. If you end up in the middle of 2 different values, so here we got 6.5, and if you start crossing off, you do end up with 2 things left over. We're going to take the average and declare that it's the thing in the middle, so here we would say 6.5. If you get given list data again, notice this is not grouped data. When we come to our number of children, which is x, these are not groups, they're still individual things. We can still use this idea to pick out median. If we've got 23 things, we're going to be looking for halfway through. We add 1, we get 24, we divide it by 2, we get 12. So we're going to look through and find the 12th thing. You can either start counting through, so go 1, 2, 3, 4, 5, 6, 7, or you can use cumulative frequency, but we should be able to see in here, this next group in here, we end up with our thing number 12. So the 12th value lies in this group, so our median we're going to give this answer as 2. It's really important to make sure you don't accidentally give 9, because that's a frequency, that's not the actual value that this group had. Finding the mean from a table of data where we get given all of the information. So notice this is not grouped data. We've not got groups here, we've got actual values. We're going to do by doing frequency multiplied by our x value. So it's this one times this one plus this one times this one. You might have met this at GCSE. At A level we're probably going to do this entirely on our calculator. So if I just show you how to use your calculator for this, we're going to be using the Casio ClassWiz calculators. I'll pop mine here, and we're going to be using the stats mode. So if you switch your calculator on, you need to go to stats mode, which is here. We're going to be dealing with one variable data, so this is data where we had x and we had frequency. I'm going to press 1. if your table doesn't have a frequency on here, you need to go to the setup options, which is shift menu. We're going to go down, we're going to find statistics options 3, and we're going to switch our frequency option on. If you've done that, you should now have a table that looks like this, and we're going to key in our data from our table. So I'm going to key in the X values first. So we have 0, 1, 2, 3, 4, and 5. And then I'm going to go up and I'm going to key in my frequencies. So for 0 we had a frequency of 2, and then 5, 9, 4, 2, 1. When you've keyed this information in, we're going to press Option up here, which is the OPTN button, and then we're going to select one variable calculations, which is option number 3. This gives us some information. The top thing up here is the mean, which is 2.08. It also gives us sigma x, which we could have used for our calculation. So either way, we get our answer straight out of the calculator. We're going to do most of these calculations on a calculator. You won't have time in an A-level maths exam to muck about and go through all of these data by hand and add up all the frequencies and all that sigma fx's. So it's really important to know how to get this quickly on your calculator. There's also only ever 1 mark given and no method marks, so you're not going to get marks for showing all this information. So we're going to have a look at a couple of examples for this, and then we're going to have a go at some yourselves. So for this one, we're asked to find some information from some data set here, which is collar size for shirts. So the mode is simply the one that's going to appear the most. So for A, we're going to go through the mode of this data is actually 16.5. 16.5. For B, we're asked to find out the median. The median going through here, does it tell us how many things there are? It doesn't. So adding up these numbers, all of our frequencies, because this is X and this is F, adding up our frequencies, I'm just going to go menu 1 to get back to normal mode. So we're going to do 3 plus 17 plus 29 plus 34 plus 12. That gives us 95. If we add 1 and divide 2, we find that this is thing number 48. So the first 20 things are in here. So if we did cumulative frequency, we'd have 3, 20, 49 from adding on that. So our frequency actually, so our 48 for the median actually ends up being, in this third class, median is the 48th thing. This is actually a 16. When we come to find the mode, sorry, the mean, C, we're going to return to our calculator. We're going to go back to stats mode. We're going to do one variable calculations. We're going to enter our X and our frequency, making sure we get these right. So we've got 15, 15.5, 16, 16.5, and 17. So we've got 5 options in there. Putting in our frequencies, we've got 3, 17, 29, 34, 12, and then option 1 variable calculation, which is option number 3, and our mean is 16.18, so 16.2. Mean 16.2. The last bit says explain why a shirt manufacturer might want to use the mode when applying production numbers. So the mode is simply the most common shirt size. So for this one, for D, the mode is the most common. So they must want to make sure that they have the largest number of shirts in a 16.5. Even though our mean is actually closer to 16, there was still more for 16.5. So this one should be the most stocked shirt. Size. Okay, so we can do simple measures either from a table or from a list using part of our calculator and partly our math skills. The only other thing we have to be able to do is work with combining means. So we've got a group 1 which has n is 25 and x bar is 6.4. There was another group, we'll call it group 2, that has n equals 30 and x bar of 7.2. And we're asked to find the mean of all 55 together. So we can't add means together. You can't just add the 6.4 and the 72 because the number of things in each group actually matters. What we're going to do is we're going to work with totals. So our sigma x, remember this is just the total for x, is going to be x bar multiplied by n. So there are 6.4 on average and there are 25 of them. So 6.4 times 25, which will give us a total number for our x's. So going back to normal mode, menu 1, menu 1, 6.4 times our 25 gives 160 in this group. For the other group, we're going to have sigma x is 7.2 times 30, which gives us a total of 216 for this group. And putting these two things together, we get a grand total for all of our 55 things of 376. So we've got our 376 things. All we're going to do now is divide this by 55 in order to get our mean. So our overall x bar is 376 divided by 55, which gives us plus 160 divided by 55, which gives us a mean of 6.84. With most applied maths things, we can have a look and decide if this seems sensible by having a look at the different things we've got. So we had 30 observations at 7.2 and only 25 at 6.4, so we'd expect the mean to be in between these things, probably a little bit closer to 7.2, and that's what we ended up finding. We're going to have a look now at a couple of questions from exercise 2a, which is on page 22. Quick reminder, you have online textbooks. There's a link to this through Moodle. If you do have any problems, then drop either myself or your normal teacher an email, and they will help make sure you can get onto the online textbook. So if you want to pause it now, have a go at some of these questions, and we'll resume in a bit. The next section we're going to look at contains a reminder on finding the mean from a grouped frequency distribution. So before we did it by doing f times x and adding them up, but for this one our data set doesn't actually give us the actual information, we just get these class widths here that tell us what the data was in between. So this is grouped frequency distribution. It's really important to spot this is different from the one before because we're going to use a slightly different method. For this one we're going to use the midpoint for each class instead of the x value. So the midpoint for this one is 2.5 because that's halfway between 0 and 5. Doesn't matter too much here that we've got equal to because the next one starts at 5, so the dividing lines for this class are 0 and 5, so the midpoint is at 2.5. This one at 7.5, this one at 12.5, the 17.5. This one, if you're not sure how to do it, we're going to add up the two things. We're going to get 80 and divide by 2, so we get 40 as our midpoint. If you're ever not sure, add up the two things, divide by 2. This one we get 65. When we come to do our calculator calculation now, we're going to use the midpoint as x and the number of occasions as f. So back to our calculators. We're going to go to stats mode, which is here, one variable calculation. So we're going to enter x as our midpoint. So this goes 2.5, 7.5, 12.5, 17.5, 40, and 65. We're now going to go through and enter our frequencies, which is 4, 15, 5, 2, 0, and 1. So we could actually have missed out this entry here because there's no frequency. We're now going to go on the option key, which is here, and then we're going to go on one variable calculations, which is option number 3. We can see for this the mean is 10.55, so we're going to give our answer as x bar is 10.6. If you wanted to get any of the data to work this out, we can see the sum of the data underneath here is 285, and if we press down arrow, we can see the answer is 27. So this has actually come from doing 285 out of 27. So this has actually come from doing 285 out of 27. So the calculator gives you any working you might want to use and any facts you might want to use for other parts of the question. Very quickly, to have a look at this other one here. This table looks quite similar, but you might notice they've changed some of the ways the midpoints and end parts of our class boundary are arranged here. So with this, we might use class boundaries. So the class boundary for here is 5.5, and the class boundary for here is 5.5. I know it seems a bit weird to have an idea of there being a decimal number of class boundaries and having half a correct answer, but this ends up giving it a better approximation for the median. So this one is going to use 10.5 and 10.5 and 15.5. The lower boundary for this one is actually 0. When you come to do your class boundary, it's these two red things that we're going to use for our midpoint, not the original things that we've got in black. So this we do if there are gaps in between our data. Quite often in the Edexcel exams they've reminded people here and they've given people another column for midpoint and they've started filling out some midpoints. But just be aware, if there are gaps in your data set, we're going to use these boundaries rather than the actual set of data when we come to calculate our midpoint. A quick reminder here, if you've missed any of the calculator stuff so far, we're going to be using Casio ClassWiz calculator for pretty much everything. If you've not got your frequency on, it's in setup stats options. You're going to add your data and then it's option one variable calculation to get things like the mean. I'll give you a bit of time to have a go at this. Pause this if you want. Have a go at exercise 2b. I'd suggest doing a couple of questions until you realise how similar they are, and then we're going to move on to the next bit. Now we get to one of the other topics where it's essential to know what type of data set we're using. When it comes to medians, it really does matter if it's those groups data where we don't know the actual data or if we know the exact stuff. So this is the method for list or raw data, so this is not grouped data. So this is anything you can write in a list where we have all the actual values. Now we've done finding medians, but there's a slightly different method that we're going to apply for quartiles. So we're going to work out how many things are there. So remember n is the total number. So we're going to work out 1/4 of n, because if you remember our lower quartile, that's just the thing that is 1/4 of the way through. If we get an integer for n, that means that the quartile is halfway in between that thing and the next thing. For instance, if you get 7, we're going to look at the 7th thing plus the 8th thing and then divide it by 2 to get an average. So when we come to do quartiles, we're going to just do 1/4 of n. If that gives you 7, we're going to do 7 plus 8 divided by 2. If you get any integer, let's say you get 7.5, we're going to round this up and we're going to choose the 8th thing, because it actually turns out the quartile is closer to the 8th thing than it is to the 7th thing. This is a little bit counterintuitive. This is one of those rules for stats that you've got to remember. For the upper quartile, we're going to do exactly the same thing. We're going to evaluate 3/4 of n, so 3/4 of your total number of things, and then we're going to apply step 2. So if we get an integer, we average that thing and the next thing, and if you get a quarter or a half or some kind of fraction, we're just going to round it up. It's always up. It's not just round it, it's always up to the next integer, and we're going to use the next value. So we can do exactly the same thing if you wanted with the median. So rather than adding 1 and then following the method of just choosing the things, you can not add the 1 and apply this rule that we've got here. Just want to take the time to mention you cannot use the add 1 times it by a quarter rule for quartiles. It doesn't work. The one from GCSE where you add 1 and half it works for the median, but no other thing. So if you're doing anything like a quartile, you've got to use this new method. If you want some time to add this to notes, you can. If you want to pause it, that's fine. To have a look at this set of data we've got here, we're going to work out first off how many things there are. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. So n is 14. To find the mode from here, we can count through and work out that there are actually most 13s. So this is 13. To find the median, we're going to count through. We're going to use the method we did before. So a half of 14 gives us 7. So we're going to go through and find the 7th and the 8th thing and divide it by 2. Because this 7 came out to be an integer. Integer, as a reminder, just means whole number. So counting through, we get 1, 2, 3, 4, 5, 6, 7, and 8. So this is going to be the 13 plus a 14 divided by 2, which gets us 13.5. When we come to the upper quartile, we're going to do 3/4 of 14, which gives us 10.5. Because this is not an integer, we're going to round this up and use the 11th thing. Let's tidy that up. The 11th thing. So counting through, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 16. Okay. That's that for that one. This here might look a bit different. This is actually a stem and leaf diagram, but it's basically a list of data. There is a small mistake on here, which every year I forget to correct. This is a 3. There are 3 things in here, and it all adds up to 52. Because this is actually weeks in the year. So, find the 3 quartiles. So to find our lower quartile, Q1, we're going to do 1/4 of 52, which comes out to be 13. Because this is an integer, we're going to use the rule, integer. We're going to round this up, and we're going to pick the 13th and the 14th and divide it by 2. So a quick reminder when you're counting through these things, we count from this side and we don't count the stem, we just count along the leaves. So thing number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so this one, and 14, this one. A classic mistake would be to write this as 2 plus 3 over 2. Because these are actually 30s, this is 32 plus 33. Because if we go back to our diagram, we start with this, and then we put this bit on the end. So this is 32 and 33. So this would give us 32.5. Using a similar method, we could find the other quartiles. I'm not going to finish this example, but we can work through and find the other median and the other quartiles using exactly the same method. This here, again, it's raw data. It's not group data, even though it's written in a table. So going through, first thing we need to do, this is our X, this is our F, is work out the total number of weeks. So if I add this up, we have menu 1, we have 2 plus 2 plus 3 plus 4, plus then there's a 6, 9, 12, 6, 5, 2, 1. 52. So it is weeks in the year again, and this is the entire year. So we have n equals 52. The mode for this is the one that appears the most often. This would be, there were 12 weeks where we had 24 orders, so the mode here is 24. This isn't a modal class, it's an actual mode because we've got all of the data. Median and quartiles. I'm just going to find the median in one of the quartiles. I'm sure you can find the other quartile yourself if you want. So the median, so we're going to call Q2 the second quartile. Some people call it the median, second quartile. It's the same kind of notation. We're looking at a half of 52, which comes out to be 26. So looking through thing number 26, the first two things are here. Let's do cumulative frequency. If I put cumulative frequency on, we have 2, 4, 7, 11, 17, 26, and then we've got 38. So thing number 26 means we should be looking at 26 plus 27th over 2, because this is an integer. So we use the rule for integers. When we pick the 26th thing, that's a 23, but the 27th is actually in the next class, it's a 24. So this is 23 plus 24 all over 2, which gives us 23.5. Just going to move the calculator so it doesn't get in the way. To do our Q1, this is a quarter of 52, which gives us 13. Again, this is an integer. So we're going to be doing the 13th plus the 14th over 2. Going through, our 13th thing and our 14th thing are both in the 22 category. So this is going to give us an answer of 22. You could find the upper quartile by doing 3 quarters. I'll leave that as an exercise to you if you want to do it. The 7th decile, this word decile actually means a tenth. So we have quartiles, which means a quarter. So deciles means a tenth. So this is finding 7/10 of the way through our data. So we're going to do 7/10 of 52, which is a calculator job. So if I do 7/10 of 52, so I do 7 divided by 10, and then we times by 52. We get this number, which is 36.4. Because this is a fraction or a decimal, so this is not integer, we're going to round up. So we're going to be picking the 37th thing. So going through, we can see the 38, all the way up to 38 is in this class. So this is actually going to be a 24. And we can finish that one off there. So we've worked out what fraction of the way through my data set is by doing this fraction, which came from the 7th decile, so 7 out of 10. Multiply it by 52, we got something that wasn't an integer. The rule for not integers is you round up. We round up to 37, we pick the 37th thing, it's a 24. So we could actually use this for any fractions. So a reminder that deciles are tenths. You could also have percentiles, which are 1 out of 100. Hopefully we realise what percentiles are. So quartiles, deciles, percentiles. Okay, in the next exercise, Only question 1 and 2 deal with this list data, and in question 1 they've given us a list which is actually out of order. I'm going to suggest you have a go at question 1 and question 2 from exercise 2C, and we'll have a go at the other ones using the median and grouped data method, which we'll cover in a second. So if you want to pause now, have a go at these two questions. When we come to do medians from grouped data, it's a bit more involved because we don't know exactly what the data was, so this is going to be an estimate, and we're going to use the idea of interpolation. So this word interpolation means to look inside a data set and try and draw some conclusions. So hopefully we can see, adding up here, we get 20, 24, 25, 26, 27. So if we were to divide this by 2, we get 13.5. Even if we rounded this up to 14, we still don't know what the 14th thing is. So what we're going to have to do is we're going to have to use some kind of method. We can see it's going to be in here to work out whereabouts in this class it is. Now there are two main methods for this. You either learn a formula or you do a graphical method. I'm going to cover both here. I'm first going to give you the formula, and if you want to spend time adding this to your notes, if you like learning formulae, this might be a good way to go. If you prefer to learn methods, we'll look at a method that you can use in a second. These two things give you exactly the same information, so it's entirely up to you which one you use. So this has the lower class boundary. We did a little bit about boundaries before. So this is not the lowest value, it's the dividing line between this class and the one before. We've got a number of observations, so a half n, because that's how we find where the median is. The next thing up here we've got is frequency, and this is the cumulative frequency up to and including the class that you're in. So up to but not including the class that you're in. So this is basically all the things that have come before the class that you're in. We've then got this frequency with class on the bottom, which is the frequency containing the median. And the final thing we've got here is the class width. It's really important to get these two frequencies the right way round if you're going to use this formula. So the advantage of formulae is you don't have to do any rearranging or anything, but we've got to know this formula. If you know learning formulae is not for you, the other method, which we're going to look at in a minute, might be a bit nicer. So we're going to have a go at using this to work out our median. So we can see here total of cumulative frequency, this is n, is 150. So if we want to find our median, or Q2, what we're going to do is we're going to half this to get 75. So this is the 75th thing. Looking through our cumulative frequency, the first 32 things arrive in this class. So our thing number 75 is going to be in this class here. So we write down our median, Q2, is the lower bound of this class. So the lower bound of this class is actually 4.5. Because this is the dividing line between 4 and 5, so we've got 4.5. So we're going to take our 4.5 and then we're going to add on a half of n, which gives us 75. Take away this cumulative frequency up to and include, so it's this 32 here. So this is the cumulative frequency before our class, so 32. We're going to divide this by the frequency of our class, which is 71. There are 71 things in this class. And we're going to multiply this by the width of our class. Now if we go to our table, we'll notice this starts at 4.5 and ends at 9.5. So our class width here is actually 5. You might look at this and go, but this class goes from 5 to 9, that's only 4. The class doesn't, the class actually goes from 4.5 to 9.5. Even though it's visits, and you might think of those as discrete things, to get an approximation we're going to assume that it's all continuous and it's all evenly spread between 4 and 5. That's between 4 and 9. So we're going to start at 4.5 and end at 9.5. Putting this into a calculator, we arrive at the answer of, so we're putting in 4.5 plus, you need to put a fraction on the top, we've got 75 minus 32. On the bottom we've got 71, and then we're going to multiply this by 5. We get an answer of 75 or 7.53. So this is our median, and looking through we should have expected something in between 5 and 9, or 4.5 and 9.5, so this is the right kind of answer to be getting to. It's kind of halfway in the middle, maybe a little bit towards 9.5. To have a look at a graphical method for this, I will put that there. We're going to draw ourselves a box, and this box, some people do it with a line instead of a box, represents the class that we're looking at. So I like drawing it as a box. So if I draw a box here, on the top of this box I'm going to put cumulative frequency, and on the bottom of this box I'm going to put my x values. And all we're going to do is fill out the information for this class. So the cumulative frequency starts at 32 and ends at 103, and we're interested in thing number 75 because that's our median. On the bottom our x value starts at 4.5 and finishes at 9.5 because those are our boundaries. So we now just have this box. We don't need any information. I've copied the information from my table down onto here. We're going to calculate this here and this here and work out what fraction of the way through we are. So if you look at the top, we have 75 minus 32, which is 43. If we take that away, we take away the 2, we get 73, we take away that, we get 43. And the entire class width is actually 71. So we are 43 out of 71 as a fraction of our way through the class. So knowing that this bottom bit here is actually 5, we can work out this length by doing 43 out of 71 times 5. So let's just do that. So this is 43 out of 71 and times 5, and this gives us 3.028. So 3.03. So we're 3.03 along our class, and our class started at 4.5. So this value here is actually 7.53, which is exactly the same answer we got for our previous method. One is a formula, one is a box method. You've got to be happy with one of these two methods. If you really like learning formulae, and formulae is a thing that comes naturally to you, then maybe go with the formula. If you prefer a slightly more graphical method which doesn't have learning the formula, it's a little bit more intuitive, this might be for you. This just works by using a ratio of how far through the class we are compared to the width of the class. So a quick summary of this formula. This formula reproduces exactly the same stuff as the box method. We notice we've got our ratio here multiplied by our class width added on to our lower bound. It's exactly the same calculation, just different ways of looking at it. We're going to have a quick look at quartiles. This is exactly the same method as before, but we're going to change the fraction that we put in. If I want to look from this and find the lower quartile, so there are 150 things, so we're going to do 150 and we're going to times this by a quarter to get 150 times 1/4 gets us 37.5. So we're going to look through this data set and try and work out where thing 37.5 is. Looking over here, we are just about bigger than 32. So it's going to be in the start of this next class. So our Q1 is going to be, using the formula, the lower bound of this class here, which is 4.5. Because you notice this class here starts at 4.5 and this one here finishes at 4.5. The boundary between them is 4.5. And then we're going to do plus, we're going to draw a fraction here. Instead of using a half n for this bit, we're going to use a quarter n, which is our 37.5. So this is a quarter of the number of things. We're then going to do exactly the same thing before. We're going to take away 32, which is this one, and then we're going to divide by our 71, which is our class width, which is this one. We're then going to multiply by the class width, which we decided, so this goes all the way to 9.5. Our class width is 5. And then we're going to put this in our calculator. Exactly the same way using the box method if you prefer. So we've got 4.5 plus, we're going to draw ourselves a big fraction. We've got 37.5 take away 32 on the top. And then on the bottom we've got 71, and then we're going to multiply this by 5. We get 4.89 as our answer. So for this one, it's really important to use our bounds, because this median is actually, so this lower quartile is actually less than our 5. So 4.89 is our median. So is our lower quartile. To find an upper quartile, we're going to do the same thing with 3/4 of n. So we're going to start off taking our 150 and multiply it by 3/4 to see what we get. So 150 times 3/4, which gets us 112.5. Looking through here, we should be able to pick out that this one is now in, let's rub out all this stuff on my table, this one is now in this class. Because things all the way up to 103 lie in these two classes, and all the way up to 123 lie in these three. So 112.5 must be in this class here. Because this is the method for group data, we're not going to round this up or do anything to this. This is the number we're going to use. So we'll notice the lower bound for this is actually at 9.5. For this one, I think I'll use the box method, but if you want to keep using the formula, you're welcome to. So on the top of our box method, we have cumulative frequency, and on the bottom we have x. So on the top of here, our cumulative frequency starts at 103 and ends at 123. And we're interested in thing number 112.5. Let's just make ourselves as much room as we need. On the bottom, we've got our x values, which start at 9.5 and end up at 14.5. So we're interested in this point just here to see what it is. So the first thing we're going to do is we're going to work out our fraction, which is 9.5 on the top, because that's what you get when you do 12.5 take away 3. The hundreds obviously cancel. Divided by our class width here, which is 20. So we're 9.5 out of 20 of the way through the class. The class width has a width of 5, so this distance in here is 9.5 out of 20 multiplied by 5. And then we're going to add on our 9.5. So we're going to have 9.5 plus 9.5 out of 20 times 5. Some of you might have realised that this method is exactly the same as the method we did up here. It's exactly the same things in the formula. It's just a slightly different way of remembering it. So if we put this into our calculator, we get 9.5 plus, with our fraction we have 9.5 out of 20 times 5 for our class width, which gets us 11.85. So 875, so 11.9 as our upper quartile. So we found our quartiles for this distribution here. This one is right. It's a little bit closer to 10 than before, because actually this isn't very far through our class. So you need to be happy with either the box method or the formula method as one of these two methods for finding quartiles. I'd suggest now you have a go at the rest of 2C. These questions 3, 4, 5, 6 are all using the grouped data median interpolation method, not the list data one that we did at the start. Have a go at these and that will conclude this lesson.